Well, what a delight and a privilege to be here with you on this inaugural event. Thank you to the organizers from all of the speakers today as well. What a great thing to do. What I'd like to do today is begin this inaugural event by talking about failure. That's what we all want to hear about when we come to TED, right? Right. The quote as the title of my talk comes from a quote from Louis Pasteur that says, "Where observation is concerned, chance favors only the prepared mind." So I want to talk about two subjects today. One is I want to talk about the importance of understanding and participating in failure, not being afraid of it. The second thing is I want to talk about some things I don't get to talk about very much anymore, which is the world of molecular biology and what that is informing us about in terms of the way that knowledge can be developed and communicated and dealt with in the realm of ideas. The fundamental subject I want to talk to you about today is innovation, and how does it happen, and what can we learn from those who have done it before and from those who have had a prepared mind and those who have failed at times. I'm not getting any motion on the slides here. There we go. Whoops. Okay. So, all right, we'll skip the other slide. All right, so thank you. All right, so one of the things we all have to wrestle with is that, and by failure, of course, hear mistake, hear anything that could potentially embarrass or humiliate you. Yeah, businesses that fail are one of the ways that we can fail, but there are many ways that we practice failure in life, and the reason that that's important is it's fundamental to success. Unless we understand that it's part of getting to where we want to go and we don't have this kind of response to it, but have something like that, we're going to get stuck at times. And we're going to get stuck at times when maybe we're right around the corner from a breakthrough. So when Louis Pasteur talked about chance favoring the prepared mind, what he was really talking about is being prepared to look at failure differently than that runaway reaction would imply. Run to it, run into it, look into it, and produce more and better questions than you would if you ran away. Allow the failure, the mistake, to invite curiosity, tenacity, invite fresh insight, random associations. My kids like to say, random, and I say, yeah, that's the way. Failure, power of failure, establishes limitations and strengths. Now think about that. How does one hone their own capabilities? How do we learn what we're good at and what we're not good at? We fail. And let's fail quickly, and let's fail often so that we can understand where we're positioned to succeed. This is the approach that I advocate in terms of I've worked in a lot of different kinds of innovation-based businesses, innovative business models as well as innovative technology. And what I find is very often this word on the bottom, serendipity, plays an enormous role in success. A prepared mind is one that looks at potential obstacles differently than you might instantaneously tend to do. So the prepared mind response to failure involves turning it into an experience observable from multiple perspectives. This comes from Leonardo da Vinci. He said he couldn't start a work until he had drawn it and seen it from at least 3 different perspectives. Failure isn't that when you look at it from more than one perspective. So in all of our businesses, all of our entrepreneurial activities, this is foundational, and we have to get over the fear response to failure. And I don't know what's going on with the mouse here. Okay, so is brilliant insight more common than we think? Now, one of the things that I just said in terms of the chance favoring the prepared mind is that, well, if you look at it differently, you might understand something that you didn't before. Very, very famous American, Henry David Thoreau, claimed that in every work of genius, we see our own rejected thoughts. How many of us have had that experience before? You see somebody solve a problem and you say, why didn't I think of that? Every great idea is obvious after you've seen it. And acts of brilliance occur regularly in everyone's life. And the question is, do we have our minds prepared to recognize them when they come? Do we have our skills prepared to act upon them in the way that we ought? That's really the first set of questions. Then I'm just going to propose some questions to you today. You're going to need to advance the slides. You can go ahead. Okay, so what's the problem? And these are some problems for us to think about as participants in this innovative society that we have and a much more innovative society that we hope to have. One may be our teaching methods. You can go ahead and scroll all the way down to the bottom of this slide. Methods, we teach methods, we teach answers. There's a defined answer, there's a defined method. Do we teach insight? Do we teach reflection? Do we open the box? Or do we only define closed boxes for students to look at? I'm in the teaching role now, so I'm trying to wrestle with how do you open the box? Research and investment mindsets. Are we looking at right performance parameters, or are we exploring the right questions? In the reward systems that we put in place, are we celebrating technical and commercial launches, those big-time events, or do we find a way to look at the incremental learning that occurs on the way to an unsuccessful launch? Do we have a way to recognize the value of learning in the development of an enterprise, in the development of a person? These are the questions that I wrestle with when it comes to wrestling with failure, wanting to give people experiences in failing and recognizing that at the end of the day, it looks nothing like failure. All right, that's really the first subject I wanted to talk about today. So that's failure. We're all done. We can all succeed now. What I'd like to talk to you about is a somewhat different idea that comes out of the world of molecular biology. I've been privileged to participate in this generation of molecular biology where we have sequenced the human genome, and more information has come out of that project than has been developed in the whole history of mankind in all other fields, just out of the genome. Amazing progress. It will take centuries to digest the information that's there. But there are some principles that have come out of our understanding of modern biology that have application in everything that we do. And they apply to the way that we handle information. We know these ideas from some things that we've seen in our own life, from a world of plant breeding, for example. By the way, that's what corn looks like in the wild. When human beings get a hold of it and begin to breed it and pull out the quality measures that we desire from it, this is what we end up with. And it's amazing. And it's powerful breeding. This is what tomatoes look like in the wild. And you breed them and you develop all kinds of diversity here. This is the power of sexual recombination. The two parents combining to form a new entity, pulling things out of that mix that you need to forward it for me. Entities that you want. Okay, so here's dog space. That was vegetable space. This is dog space. There are 4,000 positions in dog space. Dog space being the volume of diversity we can create by breeding this beast right here. It's amazing, the diversity that resides within the dog genome. Powerful, incredible ability with very slight differences to make enormous changes in the properties of the animals. What in the world does this have to do with innovation? This process by which one parent combines a genome with another, does an exchange, and creates offspring is called recombination. This is just linear information. It's information provided by two parents. The question is, does this apply to other domains as well? And the answer is it absolutely does. For example, you saw the dogs and the corn and the tomato. A few years back, I was involved in a process where we said, could you apply this to the gene? Okay, say you have an enzyme that produces a drug that you want to make. Can you take that enzyme out and breed the gene itself and create a better enzyme? The answer is yes. So the principle was reducible well beneath the level of a whole organism, and all of a sudden it changes the world of medicine and molecular biology and everything else. There's another level. The answer is yeah, it can be applied at a molecular level, change the world of the field of molecular biology. The next question is, can it be applied at an idea level? Back in the 1970s, a gentleman by the name of Dawkins had this concept of information moving around between people very much like genetic material does. And that it doesn't move in random pieces. It moves in fully, complete, usable pieces of information. And the question that has arisen now in our time, as information has become so abundantly available, is can we apply the concepts of breeding that I just showed you with those pictures to ideas? That's, if nothing else, a question I would like to leave with you today. Can you breed ideas by the way that you structure your organizations? Can you breed ideas by the way that you open your heart and mind to other people's thoughts and other people's innovations? Can you go on? Go ahead all the way through. And will it have application? And the answer is it has application virtually everywhere. Innovation is driven, this is a quote from Lee Fleming at Harvard Business School. We hold the view now that invention results from a search process in which inventors, that's us, the designers, gain information from the technology landscape and recombine the knowledge in new ways. This is the challenge that we have in front of us, but it's also the invitation we have in front of us. I talk to many groups who are not scientists by training. I don't know what this group is composed of, but this is not the domain of the engineer and the scientist only. This is the domain of the human being, participating in the generation of new ideas. So this question of recombination and molecular biology and its effect on the way that we think about things is affecting everything today. Incremental product evolution would be what I would call sustaining technology. You would make very small incremental improvements within a field. Let's say within linear computer science. You bring in some ideas of neural networks and things related to the biological sciences, and all of a sudden your ability to increase performance multiplies. This is recombinational innovation. It's exponential in its effect. This is linear sustaining innovation. If we want to be competitive in this region, and we want to be competitive in the world in the 21st century, we must figure out how to engage in recombinatorial innovation, where ideas from different fields combine together in new ways to form completely new ideas. Let's practice with this for a minute. How about restaurants? Can anything new be done with restaurants? Can you imagine a restaurant, for example, that has no place? A restaurant that has no menus, a restaurant that doesn't serve food. Stop for a moment and you kind of imagine those questions, and you might say, well, those are foolish. On the other hand, you could say, wait a minute, is the concept of a restaurant something that's open to recombinatorial innovation? What if you brought your food to the place and you rented space and you had meetings there? You know, variety of different ways to solve that problem. Let's take another example of this, and I work in the university today. If we want to teach students the importance of living and working in a world that is ambiguous, where answers are not all closed-ended and teams do not occur in boxes we call classrooms, can you run a class, can you run a course with a group of people that isn't in a room, isn't in a classroom, isn't on a campus, doesn't have whiteboards, doesn't use books? These are the kinds of questions that I'm wrestling with personally, and they apply directly to this question of how do we breed ideas? The way that we do this is we ask broad questions that go outside the domain of the field that we're working in. And then we intentionally bring in people and voices that are not in those fields to bring their ideas in. So what I wanted to leave with you today was a couple of things. To be innovative, we need to recognize failure is a must, and we need to know how to handle it, fail fast, go on through it, learn what we can, and don't waste all of our resources on the first try. Secondly, we need to open up our thinking well beyond what we've been used to doing in the 20th century to domains that are completely unrelated to the field that we're working in. You know, what does the restaurant have to do with 21st century algorithms and, neural net chips? I don't know, but I suspect there would be something there if we look for it. So I would like to start the day then by saying innovation is critical to this community and to our country going forward. I'd encourage you to stretch beyond your defined fields. And the last challenge I would have for you, and this comes out of many different lines of evidence in the literature, your greatest potential source of innovation in your lifetime will be outside of your field of discipline. Your greatest opportunity to make a creative impact in the world is not in the area in which you've been trained. Because in an area where you're an expert, you're part of the blinders. In those other areas where you're naive and innocent and you don't know those rules, you're free. That's the process by which recombination of ideas and breeding of ideas can begin. And I'd like to just invite you into that process. Thank you.